This week, with the help of Autodesk, we're going to be reinventing the wheel.
Not reinventing, they will be round and they will resemble wheels that have been made before.
But better. You may recognize this wheel. It was used on the slant nose when we did our mock-up, and also on Jigsaw on the front here when we made our fender. So our goal for this week is to go from concept to an actual physical prototype wheel that we can bolt onto the car that will embody the 1960s styling of our supercar. This video has been paid for and sponsored by Autodesk.
Our goal is to design a wheel that looks like it belongs on the car that we're building. So we're taking inspiration from wheel manufacturers from the 60s, like Campagnola, Cromodora, Halabrand. As it happens, we have a Cromodora wheel right here. This one's made out of magnesium. You'll notice one of the features is they have a lot of ribs in them to add strength. They also have windows cut out with ribs built around them to lighten it up and add strength. That was all done because of the materials they were using, the process they were using. We don't necessarily need that since we're using a forged wheel center, but from an aesthetic point, that's exactly what we're going for. We want to add these features so that it feels right on the car. So the first thing we want to do is sketch out some ideas on paper so we have a direction when we go to design this in Autodesk Fusion.
Given the nature of these wheels and how they're very important, because wheels are like the shoes to your car. You see them, you can change them out, whatever, but they're like a defining personality to how the car looks. We decided to get an additional opinion. Our friend Juan Noguera is an industrial designer who actually teaches fusion at RIT in New York. We've worked with him many times on the channel, and we consulted with him on our wheel designs and showed him Tony's sketches, and he did his own sketches, and he really liked the design. He loved his design so much that he, and I quote, texted, "In my professional opinion, Tony hit it out of the park." While Tony and Juan are working on their sketches, I have something else exciting to work on. The other week, when I did the metal shaping on the quarter panel here, I ended up with the taillight housing area not done in metal, and there's a reason for that. The idea is to have two taillights on either side and this like flat plane on the tail end of the car. We have a 3-inch one on the outside, a 4-inch one on the inside, and then trailing into the exhaust tips being in the center of the car. I want to try something different though. So what I'd like to do is 3D scan the tubing here to get the shape and the imprint exactly of this shape. And then I'm going to model what I'm going to be called a press stamp with two different sides, a positive and a negative. They're going to press together to shape the metal, the panel that's going to go here out of aluminum. Then I can recess these two circles because I don't want the lights just to be like sitting on the top and you can see the seam and be ugly. I want them to be recessed inside of the panel. I haven't tried this yet before. I've seen it done online, but I'd like to do it myself and come up with a way to do this consistently over and over again, because being able to stamp parts is a nice tool to have in your tool set, especially when it's 3D printed parts that you can stamp with, because that costs virtually nothing to print, and like a steel stamping die is many thousands of dollars. Some of you at home are probably thinking, Ryan, you're wasting time 3D scanning. You should just take that piece of cardboard, throw it in a scanner, like a computer desktop scanner, take that image, put it into Fusion, and model over top of it. Yes, I can do that. However, I have a 3D scanner. It's all in one. I literally just pointed at this for probably 5 seconds, saved the data, and now it's down to like 0.02 millimeters accuracy, and I don't have to like jump through a bunch of hoops to make that work. If you don't have a 3D scanner, you can just either take an image with a ruler beside it, or use this actual desktop scanner and put it on Fusion as well. As I often say, use what you got. I was going to run one of the prints on my Sidewinder overnight, which is a bit smaller than the Neptune 4 Max I've been using, but apparently too small, because I want to print this flat. That's a problem. That means that I need to print one at a time. And yes, I tried. I can't fit them both on the same build plate. I could try printing it vertically if I wanted to, but I'm gonna be honest, I don't like doing that because I want it to print in the orientation that's gonna be squished. So if I print it vertical, I feel like it's gonna be too weak. And if I gambled with that, I'd be down an additional day because I'd have to go back to the 2-day print anyway. So I guess we're gonna take 2 days to print this.
This wheel literally won't even fit over the rotor.
It's like a go-kart type wheel. Almost a tire, but it's a wheel, obviously.
It's a rim.
Don't! Rims are on basketball hoops and on wheels that are over, what, 24 inches? Then they're rims. So Tony just drew the Millennium Falcon for the wheel.
The Millennium Falcon is my inspiration for this wheel.
I mean, it all works together, I guess. The movie came out when?
76, I think.
When do you think they designed the Millennium Falcon?
A long time ago in a galaxy far, far away.
Exactly, so we're good.
So as I sketched out some ideas, I played around with some different shapes and number of window cutouts that we had. With these windows, I added a rib around the outside, a rib along the spoke, and I think we're getting very close to what I had in my head for these wheels.
So the style of wheel we're going for is what's known as a 3-piece wheel. A 3-piece wheel is comprised of the face, which is missing in this wheel I have right in front of me. We have the lip, which is the black portion of this wheel. Then we have the barrel and the back. A 3-piece wheel is advantageous because then you can modify it to fit different applications. You can have a wider lip, a skinnier lip, a wider barrel, and all these things add up to be a wider wheel, or you can change the diameter wheel. You can have step lips. So you can make a 18-inch wheel face, but have a 19-inch lip by stepping it up. There's a lot of modularity to it, which is a benefit to a 3-piece wheel, as well as, say, if you damage the barrel by hitting a pothole, you can replace just the barrel instead of having to replace the entire wheel. So what we're going to do now is we're going to 3D scan this wheel and barrel combo to put into the computer and use as reference to model our wheel face off of. This is like a standard 40 bolt hole. And then we're gonna hop onto the computer with that 3D model, use Autodesk Fusion, and we're gonna use that as baseline to build off of, and we should have a pretty good starting point to make our wheels. So I've gone ahead and imported the 3D scan and processed it in Autodesk Fusion here. This will give me a good reference to work off of for the wheel face. So we're also going to model the lip and barrel as well, and then we'll modify them for width-wise for the offset to fit the car the way we want it to. Now that we're all set up in Autodesk Fusion, let's dig in. So here it is, the final rough draft of our prototype wheel for Project Jigsaw. Now, as you saw in the work that we just did in Autodesk Fusion, it is surprisingly intuitive and very easy to use. Yes, there's a learning curve to it like there is with any other software, but if we can do it, you can too. We're not engineers, we just build cool cars for the internet. So if you're interested in using or learning how to use Autodesk Fusion, the link's in the description down below to find out more. So now that the wheel is made in Autodesk Fusion, we're going to export these files and then we're gonna 3D print them on our 3D printers so we have a physical form to work off of. Well, it's finished. This edge lifted off of the build plate, lost adhesion, but it righted itself in the end, so it's perfectly level at the top, so it should be fine anyway. I'm gonna put a brim on the next one. That should fix the problem. I am having so much problems with this freaking printer right now, which usually doesn't give me any issues. I think it's time to re-level. Leveling the bed of your printer is super important because that first layer you put down is the most important layer of all the layers. If you have a bad first layer, well, this happens. You get a little taco. So let's re-level it. I'm gonna do a brim this time, and hopefully we shouldn't have any more issues. So funny story, the raft would have saved me, but the layer lines that attached the raft didn't lay right, which I noticed early on, but I let it run anyway due to time. It did, however, come out great on the top. Both the pieces are perfectly straight on the top. I checked them with a straight edge, and I can lay them on each other, and they interlock beautifully now. So they'll function, they just look a little wonky on the outside, but honestly, I heavily relate to that, so it's fine. In the past on our channel, we've had a lot of success using 3D prints to shape metal. We've made bead roller dies that work on our hunting cart project. We made this very solid hunk of plastic for shaping the rear bumper and front bumper of the 911 to backdate project. And on Jigsaw on the front, we use these forms to shape the opening for the front radiator and the fog lights. So using these forms to stamp is adjacent, but still a new thing for us. I don't know if I have 100% faith in these. I think I could have printed them a little bit more solid, especially this one, because I had a layer issue. It actually, like, if I push on it, you can hear it crunching.
That is scary.
Yeah, the aluminum is soft, so it might still be okay. The other thing that I wish I had done differently is I wish I had put holes in the center here that we could put bolts through to locate these into each other. Because right now, if I have metal between, these could potentially walk when I stamp. So the idea is we're going to clamp them together in the correct place, like a sandwich, and then press them in the press. This is why it's an experiment and not the final product. This is just step one. But before we do anything, we gotta cut some metal down so we can stamp it. Our test piece is cut. Now this is 3003 series aluminum, so it's pretty soft. I can bend it by hand, but it still is hard enough to hold a shape. So I'm hoping it's the right balance for what we're gonna do here. Let's go over to the press and find out. All right, we're back in our tiny little corner with the press here. I got my lower piece, my metal, and then the positive to go on the top. We're gonna align them to each other, and then we're gonna set them in the press here on this heavy steel on the bottom. And then the plan here is to sandwich it with this thick piece of aluminum on top to distribute the pressure equally. Then we're gonna run the press down, and hopefully we get a good result. Gonna lube this thing so it helps with the stretching of the metal. right, let's see what happens. I'm not going to use the air. This press works with air, but I'm not going to use it because I want to be able to feel the pressure by hand. Here it goes. We're nice and aligned. Sounds crunchy.
Yep.
Which I expect. Ooh. Know what that sounds like? That sounds like my knees in the morning. Yeah, oh, it's pressing though.
It is.
Look at it
The
go.
metal's coming together, yeah. It may be one flat sheet still in the middle, but
uh-oh.
that wasn't a good.
That wasn't a good one. You can see the upper piece completely mushed. The bottom piece standing solid, and the bottom piece is the one that printed well. The upper one did not. I think I'm just gonna keep running it through.
I'd give it another crank or two. After
Yeah.
that, it's not gonna do anything.
Yeah, that's donezo. But
That's an official fail, buddy.
Yeah, that's why we test these things, I think.
That's what these tests are for.
Yeah. All right,
Okay,
let's see what kind of mess I caused here.
I got a feeling that the aluminum sheet shaped our plastic piece.
I'm not surprised by this outcome by any means because of some mistakes I made with the printing process. All right, ready for the big reveal? Ready?
I'm ready.
Dun 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 dun. Well, it kind of got started a little,
but yeah, nothing happened at the taillights.
Got a little bit of a bend, but that was about it.
Yep.
The bottom piece survived though.
Yeah. That's
Like it's
maybe it's just our hammer form.
no, genuinely, it's this. This was the one that for some reason.
I mean that is now a hammer form instead of a
that you know.
instead of a.
You can try it quick. Want to see what happens?
Yeah, we might as well.
I had issues with printing. You can see how the support material just didn't adhere well. Whereas this one printed a lot better. See how loose that is? I think the other thing too is my settings reset. So I printed this lower piece that survived on like 2 days ago, right? And I printed this one yesterday. When I reopened the software to reslice it, I think it reset my infill settings and I missed that.
It's time for plan B.
I don't think it's working.
It's not.
The plastic is absorbing too much of the blow.
The plastic is not defining the shape of this aluminum.
Well, we tried.
All right.
One more thought I thought we could maybe have done is anneal the aluminum first to make sure it's extremely soft. I'm wondering if this is hardening sitting on the shelf maybe, because it feels like it's harder than it was when we ordered it, Tony. Annealing it might fix it. However, we're gonna stop here with this because we've already kind of destroyed everything. So what we learned is print it right.
And make some design changes.
Yeah, so we're gonna revisit this in a later video and do gooder next time. So we haven't failed, we just found a way that this doesn't work. Check it out, I was down to the last line of filament on this spool. I gambled, and it looks like it paid off. Nice. Big boy. Oh, that was satisfying. So that is all support material and was used to keep this, your hub, in location and then the face floating. In hindsight, I probably should have printed just the face and the hub separately to save time because there's a lot of time wasted on this material. We have a face now, let's keep moving. Before I spend too much time cleaning up this wheel face and getting it ready to be bolted on, we need other parts printed. So I'm gonna fire up the Ornstrom Giga again and we're gonna print the front lip and maybe we can keep the metal wheel barrel and bolt it all together to save some print time, but we'll see how it lines up. This is incredibly exciting. And if you're like me and you're into cars, you've always wanted to make your own wheel because you want to make everything your own, right? You don't want to have to just buy everything off the shelf. You want to make it all yourself. This is a huge step towards that. And being able to 3D print in like our own office at the shop, this kind of blows my mind. 10 years ago, I wouldn't even have thought this was possible. You see it in like sci-fi movies, but it's real. We're back down in the shop. We have our wheel face, we have our wheel lip, and we have the original metal barrel, which this all should fit together with. What we'd like to do is assemble it with some bolts, but we also have this tire we had in storage that should fit around it all. Now, we're not gonna be able to inflate it, but it should give us a good idea scale-wise what we're going for, because I'm pretty sure this tire is the right diameter.
That's the size we're shooting for. If you've never mounted a tire on a plastic wheel before, that's because people don't do that.
Yeah.
It's gonna be a little tricky trying to get things together, but I have faith we can do it.
Yeah, we'll be fine. So it turns out the tire would need to be stretched a little bit to bead, which means to be wider than the tire's meant to be. So plan B is, just because we're doing mock-up, is we're going to take some tubing here, wrap it along the bottom, and then set the tire on top of it so it pushes the tire towards the front of the lip, just so we can get a good idea of how it's going to look. It's not, going to be functional, but it never was going to be anyway. It's 3D printed, so yeah, let's get to rigging. That. Now, there you go. That looks kind of like it's beaded. I just had a thought. Where are our extended lugs? So this is an extended lug for when you have like extra wide wheels. And I think it might be too short. If I slide it in here. Yeah, there's like maybe a thread poking out there. There's an oversight, we messed up. Well, this is why you 3D print things before you mill them out of billet. So you can find these problems. You know what? I have an idea. These are thread and wheel studs to convert a Boxster or 911 or any car that has wheel lugs to have studs instead. So I'm gonna put a couple of these in, and then they'll be able to hold the wheel on the car up in place at least, so we can see how it fits otherwise. See if I can get this thing on here without misaligning it and stabbing everything out.
That's awesome. I'm speechless apparently. It's just really cool to be able to think of something and then have it, show up on the car like that.
And not have to spend like many thousands of dollars to have it machined first.
Right, yep. And know that your offset's gonna be right. If you wanna make any tweaks to the design after you actually see it in 3D, you can do it, reprint it, and have it exactly what you want it to be before you spend all the money.
Oh yeah, well not only that, so the printer we used for this was a little overkill in size, but it's roughly a $2,000 printer, I think. It's like $2,000 or $2,500. I think that printer is cheaper than having this face milled once for a machinist.
Probably, right.
Definitely cheaper. So put that in a cost perspective kind of thing, I think we're doing pretty good. And for a first go, I think it turned out really good. And the only glaring issue was the lugs, which is an easy fix. It's a very easy fix. And it doesn't even change the design of the wheel. Actually, make it look a little better because then it'll be these holes will be in
the
deeper.
lugs will be recessed. It reminds me of a model car. You punch the little wheels out of the cards tree.
The cards, the card trees. I think you did a really good job, Tony.
Thank you. Appreciate that. Obviously, I don't know if it's obvious or not, but I didn't do any of the CAD work. So I appreciate having people around me that can help with that sort of thing.
The team. This is an 18-inch wheel in the front of the car. We're doing what's called a double stagger. So the front wheel is going to be smaller in diameter and width than the rear. The rear we're planning on doing a 19-inch wheel. which means this design might change a little bit in the rear. We haven't decided that yet. We might do the exact same pattern, but bigger, but I think it'd be kind of cool to have completely different designs.
We did talk about a completely different design, front and rear, because back in the 60s, a lot of times you had that because if they were doing something with different widths or different diameters, they couldn't always get the same wheel in different sizes. So you would see a different wheel design front and rear.
Yeah. So huge thanks again to Autodesk for sponsoring this week's video. Autodesk Fusion is a phenomenal piece of software. You should check it out if you're looking to get into any kind of CAD work. And again, I'm going to say it one more time, we are not engineers. We have not been trained to do CAD work. Whereas Fusion has tons of options and huge complex things you can do with it, there's also a not steep learning curve to get started. So check it out, the link's in the description down below. Let us know what you guys think about the wheels, and we'll see you guys next week. Thanks for hanging out in the shop with us.